Welcome back to Blender's procedural bridge course. In this lesson we will create a basic shape of our bridge from the profile shape which we made in previous lesson. We will also add displacement so the bridge will have more interesting shape. So currently our profile looks something like this, and now let's actually sweep it along our base curve to get the basic bridge mesh. So here we have the setup which we created in previous lesson. We can actually make it more nicer with framing all of these nodes, so you can select all of them, hit Ctrl J and F2 to rename this frame. We can call it, for example, profile. And now let's create the base mesh of our bridge. To do that we can add curve to mesh node, which will create mesh from our curve. And this node has two inputs. First one is the curve along which we want to sweep the other curve, and the profile curve is the one which will be swept along the curve. So the profile curve will be this thing which we made in previous lesson, and the base curve will be curve which we get from the group input, or basically this curve which is created by the user. So let's take group input and geometry from this and plug it into curve. And now if we take a look at the result of this curve to mesh node, you can see that we have something which looks almost like the thing which we created, but first it looks like it's flipped. So that's first thing which we need to fix. And also it has shade smooth by default, so we will disable this feature. So first one, let's disable the shade smoothing, so we can add set shade smooth, edit after the curve to mesh node, and we can disable this checkbox which will disable shade smoothing, and now you can see that we can nicely see geometry of our mesh. And let's also flip it, so I'll add transform geometry, and we will just need to scale it. I think it's y-axis, so it's in the right direction, and we will set scale on y-axis to -1. Now you can see that we have very basic shape of our curve bridge, and we can also check this fill caps so we get geometry at the end of the bridge. And now if I, for example, change the curve or just move the points somewhere else, you can see that the mesh is responding to these changes and it's working nicely. You can also see that if I move this point upwards, this bridge gets rotated, and that might be an issue, so we can fix this by setting normals of our curve to the z-axis. To do that we can add set curve normal node, which will add, or it will change normals of our curve. The reason why we need to change these is because the rotation of these swept curves depends on the normals. So currently the normals probably look something like this, and we want them to look something like this, so they point upwards to the z-axis. So that's exactly what we can do with the set curve normal. So I'll plug it before the curve mesh and after the input geometry and set it to z up. And now you can see that our issue is fixed and our bridge is not rotated anymore. I'll change position of our point back to the ground plane, but you can see that it doesn't have any problems with points which aren't on one plane. Now the next thing which you would like to control is actually elevate the middle of the bridge, so it looks something like this. First thing we will need to do is actually figure out which parts of the bridge we would like to displace. So if we look at the profile of our bridge, we want these two bottom vertices to stay at their current position, and we want to move all of these vertices on z-axis. So to differentiate between them, we can create a selection which will select only these top points and exclude these bottom points. We can do it before creating our mesh. So let's create a new attribute which will tell us if those are the points which we want to move or not. So let's add store named attribute, and we will call this attribute top. For example, its data type would be boolean because it's just either true or false, and we will figure out now the value. Input geometry will be our profile, and we will plug output of it back to transform. And now to differentiate between these points, we can for example use position, and we can see that position on y-axis of these points is 0, and for these points it's something larger than 0. So we can differentiate between them with this. We can add position node, separate it to only get the y value, and we can say that if it's greater than 0, it will be our top, so we can plug the result into value, and if it's 0, that means that it's not greater than 0 and it will be false for the bottom vertices. We can view this value by using Ctrl-Shift to add viewer, and I can also Ctrl-Shift left click our value, and you can see that those are white and those at the bottom are black, which means that the top value for these is 0 and top value for these is 1. So those are the values which will be stored here in the name attribute, and we can use it after creating our base mesh for displacing the top parts. To displace them, we can add set position node, and for the selection we can use our attribute which we created previously. We will select it here and plug the attribute into selection. And now if I move the value on the z-axis, you can see that only top parts of the bridge are moved and the bottom stay at their position. We don't only want to move these points by constant value, but we want the value change from 0 to some height and back to 0. We can achieve this shape by using, for example, sine or cosine or some other functions, but we will stick to sine. And what it means that we want some value which will go through 0 to pi, where if we take the sine, it looks something like this, and here it's 0, here it's pi, and we will use this curve to create this kind of shape of our bridge. To create this value between 0 and pi, we can use parameter of our base curve to figure this out. We can't use a spline parameter here without capturing it before creating the mesh, because at this point we are not working with the curve anymore, but we are working with the mesh. To get the spline parameter, we can capture it here before converting our curve to mesh. So I'll add capture attribute, and we will be capturing a factor from spline parameter. So if you add spline parameter node and plug factor to the value, and now we can again use viewer, so Ctrl-Shift, and we will select mesh from curve to mesh and attribute from this capture attribute. You can see that here it's 0 and here it's currently 1, but if we multiply it by pi, we will get 0 to pi. So let's do that first. We will add multiply, and you can type pi here, which puts a pi value. And now if we view this value, you can see that it's from 0 to white, but it's white somewhere here, so that means those are some larger values than 1, which are the pi. So now let's actually create a function from it. We can use sine to do this, and if we now plug this value to the Z socket of this offset, so we will use combine XYZ, and plug result of this sine to the Z axis. You can see that it's going from 0 to some offset in the middle, and then back to the 0. We can increase this displacement by multiplying this sine by some value, so let's add multiply between sine and combine XYZ, and if we multiply it by some value, you can see that it's getting higher. And also, to make this a little sharper, we can use power here, which by default sine looks something like this. But if we use sine squared, it will look more something like this. So if I add power here between sine and multiply, you can see that if I increase the power, it stays at the 0 for a little longer and then quickly elevates to the 1 in the middle. So this is more controls which we can use. And now let's actually create some parameters which will control all of these values. So what we will want to control is this power, which is the shape of it, and then the multiply, which is the displacement on the z-axis. So I'll hit N to bring up this menu and create a new input called displacement height, and one more attribute which will be called displacement power. We can set some default values for them, so displacement height can be default to 2, for example, and minimum to 0, and displacement power can be default to 1 and minimum also to 0. And now last thing which we need to do is to plug these inputs to these nodes. So I'll plug displacement height to this multiply and displacement power to the power. Now if I reset these values to their defaults and maybe increase the power a little bit, you can see that we can control overall shape of our bridge. One last thing we can also do is to clean up those nodes a little bit. So I'll first group 4 of these 4 nodes and call it top selection, because we are selecting top vertices in this part. Here is the transform node which fixes the flipped profile. We can call this part displacement. So also Ctrl J and F2 to rename this frame. And these nodes in the middle, we can call this curve vector, because we are capturing original vector of our base curve, and these 2 nodes are converting our base curve and profile to the mesh.